On the main stage, we have Adam, Jesper, and Maximillian from the AWS team giving you a web shop on the Gateway Load Balancer. So I understood that you're all getting an account that you can use for 14 hours?
48.
48 hours to tag along and play a bit after the session. So please a warm welcome for Adam, Jesper, and Maximillian.
Testing, testing. Good afternoon. Hi, my name is Adam Palmer. I'm a specialist network solution architect. I work for AWS, based in the UK. And I help customers with network stuff, connecting their hybrid data centers and building networking stuff on AWS. And actually, security as well. A big part of networking is also security, so we cover solutions that require packet inspection, layer 7, layer 3, layer 4, that type of stuff. And with me, my colleagues, Jesper and Max. We're going to run a workshop today. As Julian said, I think this might be the first time you've done this at SuriCon. So we'll see how that goes. What we're going to do, and in true workshop style, we have stickers. We've left them out there because there was no lectern there was no sort of table, so we've left them on the table out there. So if you want an AWS sticker, first come, first served. I think we left them just outside. So why are we here? Oh, by the way, that cuddly creature there, his name is Jerry. My daughter named him just before I came here. And you'll find Jerry throughout the presentation. Jerry, SuriCon, Jerry. We've been introduced. We can continue. So we're going to do a bit about why we're here, cover last year, go through a bit of routing connectivity and sort of the fundamentals of Gateway Load Balancer, and then explain the workshop infrastructure. And then I'm going to hand over to Jesper. And Jesper is going to run through the workshop live, and you'll be invited to follow along. We'll give you all an account to use, but you can just sit back and relax and watch the demonstration if you choose to as well. So why are we here? So, class of 2021. In 2020, AWS launched AWS Network Firewall, which was a fully managed network inspection service. And with a lot of help from the OISF and AWS, we delivered that solution. It has two engines. It has a stateless and a stateful engine. The stateful engine is SuriCata. And there's some AWS componentry as well that does packet level inspection. And when we launched that, we launched another product around the same time called Gateway Load Balancer. Now, behind the scenes, Network Firewall uses Gateway Load Balancer as the scaling framework. And in order to use Gateway Load Balancer as a security device, I come a bit closer to the mic. I tend to walk around, so I should probably not do that. In order to use Gateway Load Balancer, you need to support the GWLB protocol. It's an encapsulation protocol that basically takes a client packet, wraps it up in a standards-based packet, and then sends it off for where it can be decoded. And what this meant was, it meant that once we launched Gateway Load Balancer, it was available for partners to use. But almost straight away, we had customers saying, this is great using partner devices, but can we do open source? And the default response was, yeah, we should check. Of course, it's absolutely possible. Linux supports GWLB. And so this gave myself and Jesper the kick we needed to sort of put some pseudocode together, maybe build a reference architecture, put it in GitHub, something that customers could use. And that's exactly what we did. We put a blog together, we built some code, it's in AWS samples, and effectively this builds out an inspection solution using SuriCata inside or behind Gateway Load Balancer. But we took it one step further than that. We took it on a roadshow. We turned this code into a workshop that we delivered at reInvent, which is AWS's sort of North Star for our technical conference. We run it every year. We also took it to Reinforce, which is a security-based conference, and we're here today. We've also delivered it several hundred times throughout Europe, and most of our staff at AWS are familiar with the solution as well. So it's got a bit of traction, and we thought it only right that we bring it to you. So here we are. So challenges solved by Gateway Load Balancer. Customers obviously spend a lot of their development tokens, time, money, expertise, you name it, in working with partners for payload inspection, packet inspection, that sort of thing. But I think it'd be fair to say prior to Gateway Load Balancer, the story of deploying security devices on AWS was less than easy. There were some caveats to it. You typically had to have a single route and a route table that pointed to one elastic interface, which is a virtual elastic interface, virtual interface if you like, of a security device. And if that device failed, you'd have to have some sort of heart-beating methodology or mechanism in there to detect that and fail away. Also, it sort of means you tend to have devices sitting there dormant, active, passive, and wasted investment, that type of thing, and then you end up scaling it up. And these are some of the challenges. And of course, moving to the cloud is not something that we want to be seen as a blocker for customers bringing their security devices, right? So what does Gateway Load Balancer do? Well, Gateway Load Balancer effectively acts as a bump in the wire, a transparent hop for a client trying to reach a target. And we do that. I have a slide to show this, on exactly how that works. And effectively, from a client perspective, they send a packet out on the wire. It goes to a special type of endpoint through Gateway Load Balancer and then on to its destination. So what are the typical use cases for this? We have many customers that use cloud-native constructs, of course. In AWS, you have the concept of security groups, which are effectively stateful firewalls, NACLs, that type of thing. But customers also want to bring their devices, and that's absolutely fine. And so we have partner solutions. And when Gateway Load Balancer launched, we had a load of launch partners in there. You can imagine Fortinets, Palo Altos, those sorts of customers or vendors. But of course, Gateway Load Balancer is available, as we just explained, if you support Geneve, which Linux does, to build your own inspection services. Actually, I wanted to catch up with the OpenSense guys to ask them about the Geneve protocol, so maybe I'll catch them afterwards. And so, yeah, if you support Geneve and you're a customer that likes to do open source, then you can absolutely build your own Linux instances behind Gateway Load Balancer. Okay. A typical representation of what this might look like in terms of a flow. If you weren't using a Gateway Load Balancer type implementation, various levels of snap happening there. You can see that the last actual packet to go out on the left-hand side on this network load balance, for example, actually has the source IP of the firewall. So that means all flows would go back to that firewall, right? If you take the Gateway Load Balancer example here, pre-NAT, because obviously you wouldn't see a bogan address like a 10/whatever on the public internet. That packet actually goes to a special endpoint, goes through a Gateway Load Balancer implementation, and then onward to its destination. The return packet comes directly back to the source instance, okay, after NAT translation. And this is something we call bump in the wire. What are the constituent parts here? Let's get my laser pointer up. I'll move some of these slides on. Awesome, look at that. So there's really sort of two parts to Gateway Load Balancer. You have the client side, with the consumer piece, and then you have the provider side, which is really nice, because it sort of enables sort of, disjoint management domains. You can have InfoSec, SecOps, managing the inspection architecture away from the consumers, and then you can have the consumers deciding whether they're going to make use of that. So it's nice, sort of a split domain role, if you like. And that's really the top part here. So up in this location here, you have a consumer VPC. And into that, a VPC, by the way, is a virtual private cloud. I assume some knowledge of AWS, but just shoot me down if I say something, nobody knows what that term is, just throw something at me. A virtual private cloud, if you like, is a democratized piece of software-defined networking. As a customer, you can go into AWS and you can build a VPC which gives you full control over CIDR ranges, connections, hybrid termination, VPNs, all that type of stuff. So really, if you look at this, this would be a sort of a layer 3 DMARC. Nothing comes into a VPC or a virtual private cloud unless you attach it to another VPC or another construct. So you have full layer 3 connectivity control over a VPC. So you can see here from a consumer perspective, they can be doing what they like. They can be building things in that VPC. And the provider over here can actually build the inspection mechanism. And then they can advertise it to the consumer and say, hey, listen, if you want to inspect your traffic before we go to the internet, here's an endpoint, connect to this, and we will inspect the traffic for you. So there we have it. That's Gateway Load Balancer at a glance. Now, I know we did this last year, so I'm going to move on. But check out last year's stream where we talked a bit more about this in depth. And yeah, if you've got any questions, just hit me up. So I spoke a little bit about consumers and providers. What are the sort of, from a customer perspective at AWS, what do they tend to build? Well, this would be an example, if you like, of perhaps an organization with business units that don't necessarily have the same governance track as each other. They might be completely autonomous units within an umbrella business. And so VPC1 and VPC2 could be completely different business units. They connect to the internet on their own. But actually, you have a central entity that says, hey, we've got this service. And what that central service do, or that central team would do, like I say, they would build this gateway load balancer service, perhaps using our friend there, Jerry, SuriCata. And they would advertise this in. And then those folks can choose to use that inspection service as they see fit. And actually, just running back to this would be an example, I think we put that in there. This would be a north-south. So this is basically a client connecting to the internet using the service for their inspection. Another example might be where you're having a central inspection service attached to a construct called Transit Gateway. Transit Gateway is a highly scalable modular routing architecture in AWS that enables you to connect thousands of virtual private clouds together, VPNs, hybrid connections through things like Direct Connect, which is a private optics service with AWS, SD-WAN attachments, etc. And in this configuration, we might have all of these VPCs belonging to a similar business unit. They all have the same hybrid requirements, but actually, you want to provide a filtering service. And so you attach a VPC that has some filtering mechanism inside it, and you route all of your traffic to your transit gateway, you inspect that traffic, and then you send it on its way. Another example here might be east-west inspection. What about if VPC1 needs to be inspected, the traffic from it, before it speaks to VPC2? You can absolutely do that. So if you're using Gateway Load Balancer attached to Transit Gateway, you would set your route tables up in such a fashion that traffic went towards the Transit Gateway, was inspected, and then sent on to its destination, which could be the internet. It could also be this east-west mechanism, if you like, VPC1 to VPC2. So quite configurable, lots of different patterns supported. And what we don't show on here is that you can do all of your hybrid attachments with this as well, right? So if you've got lots of different data centers connecting into your AWS cloud, you can attach those VPNs, et cetera, into this transit gateway, and then you can inspect the traffic north, south, east, west, however you see fit. So it's one thing, I suppose, thinking about scale horizontally, and that's what Gateway Load Balancer enables you to do. But it's also quite prudent to be thinking about your operations from a DevOps perspective. As I'm sure you all know, DevOps is the Venn diagram, the overlap between development and operations, the idea being that you ship code in a consistent way. You don't throw things over the fence and expect operations to implement them, right? You work almost as a two-pizza team, as we call them in Amazon. And it enables you to iterate and deliver your software more quickly and more efficiently and roll back, right, if there's any issues. Well, network devices shouldn't really be any different. And net DevOps is DevOps with net in front of it, if you like. It's applying DevOps principles to automation and configuration of network devices. At Amazon, we make somewhere in the region of 3 million network changes a week. There's no way we could do that without sophisticated automation. And so from that perspective, we sort of use the DevOps principles for our own automation in the network. And so when Jesper and I were putting this together, we, of course, wanted to embody that. And so we had SuriCata. We knew we wanted to use it. It works behind Gateway Load Balancer because it can decode Geneve, because there's a module in there that actually decodes those payloads. We thought, how are we going to take these DevOps principles and apply them to a service that we could then go to customers, go to the open source community and say, hey, listen, we've got this pseudocode here. It works. Probably not prod ready. You want to probably think about your scale and your metrics and things like that. But how can you make it better? And we're actually hoping at some point you folks will say, Adam, we could do this better this way. Why are you using that PCAP feature for there? You should be doing this. And that's exactly what we like. So, we will take your feedback. We'd really welcome it. And so, Adam, how do you do this? What tools do you use? Well, it's a good question, and I have a slide for that. So infrastructure as code is a really good place to start. You can define on AWS, not just AWS, but other clouds too, you can deploy or think about deploying your code in an intent-based fashion. And you probably start with an ISE tool. So on AWS, that would be CloudFormation, where you have a JSON or a YAML descriptor that tells AWS how to go and build your architecture for you, and we do the heavy lift. You can also use CDK, the Cloud Development Kit, which has support for many languages, and if you're someone that writes in Python or Java, TypeScript, that type of thing, you can use those constructs. You can download the constructs of the CDK, and you can start to build infrastructure as code using the modules that you're used to and put them into your workflow. So there's no sort of real limit in that respect. The next thing you're probably going to want to do, though, is have some sort of managed source control. It might be GitHub, it might be another. On AWS, you can use Code Commit, which is a fully managed Git repository service. And it's really nice because if you use these tools, they all can speak to each other natively. So you've got your code, you've checked it into Code Commit. Excellent. What are you going to do with it next? Well, the next thing I'm going to do, sort of embodying that CI/CD approach, I need a pipeline tool. I need something that's going to look at a trigger and say, well, someone's committed this to master. What does that mean? Well, that's where you might use Code Pipeline. So Code Pipeline effectively enables you to deliver or structure your code delivery routines. It's got lots of different hooks you can use. My favorite is Code Build, because Code Build can do lots of things. Code Build gives you a virtual environment in which you can compile code, write scripts, you name it, lots of different things there. And it's generally the first place where you might take a CloudFormation file, for example, and sort of render it, maybe upload it to S3, maybe transform it in some fashion, maybe send an email. Lots of different things you can do there. Onward from there, you might use something like step functions, which is another workflow management tool that can go off and do things and wait a long time for them to happen. Maybe it's going to go and coordinate a whole fleet of services to do something and then report back to Code Pipeline that it's finished so the pipeline can continue. And then you have Code Deploy, which at the end, with your packaged, compiled, ready code to be deployed to the network, you can push out natively. Perhaps it's a physical environment. Perhaps you're going to have to use some sort of REST conf or web conf, API to push that out to a physical device. Or maybe you're doing a Yang data modeling or something like that, where you're trying to standardize your configuration across lots of different vendors. Perhaps you're going to do that. And then you could write a webhook to go out and talk to, maybe using Lambda, to go out and talk to an endpoint device and configure it. So lots of extensibility, very, very configurable. And so you will see that in this workshop, which we're going to get to next. So the workshop infrastructure. So we're going to run a workshop today. Effectively, you're going to be playing a network security architect, or security architects. And there's going to be a whole bunch of findings that you need to mitigate. We're going to give you a console. You're going to have a health dashboard. And it's lightly gamified too. We do have a scoreboard. And so when you join the service, you can give yourself a team name, and we'll be tracking scores there, just for a bit of fun. So you will see, the way this works is that you will start, and everyone have a score of 0. You'll need to do some fundamental routing configuration changes to get going. So effectively, your traffic is working great today. You're going to need to reroute that traffic through the Gateway Load Balancer service using some route table adjustments, okay? And then after that, you've got 2 or 3 things that you need to write a mitigating rule for. In the first module, which I will cover in the next slide, you'll be doing some Lua scripting. Yay. And some other IPS rule-based writing. There are other modules, but I don't think we'll get to them today. If we do, amazing. But like I say, the workshop will be running for 48 hours, so it'd be great to hear whether you get any further later on. Do let us know. All right. So how does the inspection service come together? So the actual stack itself has its roots in CloudFormation, as we just saw. The first thing it does, it builds out a filter, virtual private cloud. It then builds out an ECR repo ready to put a container image into. We then define an ECS service, which is Elastic Container Services. That's effectively managed Docker. So we're running SuriCata in Docker here, in containers. That ECS service is attached to an auto-scaling group, which is a method for scaling compute resource on AWS. So you can have things in there that look at metrics. Perhaps you're tracking CPU utilization. Perhaps you're tracking network bytes, packets in, out, that, or maybe a custom metric. Maybe something you're exposing from an instance. And that auto-scaling group will scale up those instances and add more instances in depending on what you've defined in your auto-scaling group. The stack goes on to define an ECS task. That ECS task is made up of 2 containers. We have a Suricata container where we're running 6.x. I think we're running 6.0.0.0 actually. So we might need to update that to the latest build. And we have a rules fetcher container, which is effectively a piece of code that goes off and pulls rules to be changed from Amazon S3, which is a storage service. So going back to this sort of position of how we've got Gateway Load Balancer, and we're going to scale out, and we've got Suricata running containers behind it. But how do we write a rule and make sure all our containers get it? What's the best way of doing that? So Jesper and I thought about this for a while, and we decided to use the native tools. So what we're doing is we're using GitOps for this. We've got a location in code commit where we write the rules, and you can upload them as a text file or an API. And the minute you commit that change, the pipeline runs. And then we use the rules fetcher container to pull them down from S3, load them into the instance, and then call various services to refresh the rules and load them. So we can see that here. So we activate the pipeline. We commit our code, sorry. That activates the pipeline. On the first run, code build will build the containers and drop them in the Elastic Container Registry so that we can pull them in. That's a private repo. So that means only you as a customer can get to them. They're your images. On subsequent builds, we do an analysis of the containers and we say, this is the same hash as the container, we don't need to rebuild it. All this is a pull down from S3. And then the rules fetcher container goes on and says, thank you very much. Here's your new config files, loads them in. We actually have the capability to pull in the proof point rules as well. So based on the configuration, you can build your own rules in here and put your own custom SID references in. But you can also pull in external rule sets just by specifying them in one of the cluster configuration files. Jesper will show you that when he does the demo. Once all of that is ready to go and it's live, those instances get attached to the Gateway Load Balancer instance. And you can see here, the full thing is fully GitOps driven. There's no real human interaction here. We're using code commit as the source repo for our code. So there are 3 modules to this workshop. Is everybody with me okay so far? Everyone had enough coffee? There wasn't much coffee out there, but what there was, I'm glad you grabbed. There are 3 modules to this workshop. Now, just to set the expectation, from an Amazon perspective, this is what we call a level 400 workshop, so it is pretty techy. But some of that techiness is because we had to assume that nobody had any Suricata knowledge. Now, looking around the room, I think we're full of experts here. As you can see where I crossed out on the very first page, we're not going to be teaching you about Suricata because you are the experts in the room. But we can't necessarily make the same assumption about the AWS environment. So what we're going to do, we're not going to just get you going and say, put your hand up if you get stuck. What we're going to do is we're going to do a live demo of Module 1. And then we're going to say, if there's time left, and there's time left after the session today, please feel free to run Modules 2 and Modules 3 and give us feedback. All right. So, website application Module 1. So we have an application running in a private subnet. You can see, let me get my laser pointer back up. There we go. So we have a private subnet here, and what that really means is it's a subnet inside a virtual private cloud we've carved out that doesn't have access to the internet unless it goes through a NAT gateway. So it has to be translated to get out. A public subnet, as you can probably guess, means that it has an elastic IP attached to it, which is a public address. Okay, so it can be reached from the outside. Clients can initiate connections to it from an external location. If we expand this, we have a load balancer in our public subnet, which has these public addresses on. So it's a VIP, if you like. It's a DNS-resolved VIP with a public IP, and the targets behind that network load balancer are the services, Service A and Service B. This VPC is attached to our Transit Gateway, but that's actually irrelevant for this module. And there's your inbound flow. Traffic comes in from the outside. Customer will do a dig on a DNS address. It will round robin between both those locations. You see we've got availability zone A and availability zone B. They are distinct geographical locations within something AWS calls a region. And each availability zone is made up of several data centers in different locations as well. But availability zone A will give you an IP address for one half of the load balancer, and subsequent digs you might get the other half. But they will all get you to the service that's being provided behind the load balancer. We go back to this. So yes, access to the website application is unfiltered and unprotected. So at the moment, what's happening is there's no traffic inspection at all. And yes, it is port 80 we're using for this, because it would have been more difficult to do TLS decryption. We didn't want to go down that way. And so what you're going to do is you're going to implement some filtration between the internet and that public network load balancer. And you're going to write a rule to block some traffic. When you've done that, our monitoring system is going to say, well done. And it's going to give you points. And then your points are going to start to rack up on the board. And you can see where this goes. All right. So the default architecture looks a bit like this. And you've got modules 1 to 3 in here, so you only really care about this VPC here, website. You need to configure something called ingress routing. Ingress routing is a slightly advanced concept where we can basically make a more specific routing decision on your behalf. You say, I'm trying to get to TCP port 80 on that elastic IP, which is the public IP. We can say, no, you don't really want that. What you want is the firewall. And then the firewall will inspect your traffic, and then we tell the firewall that actually then you send the traffic back to that instance. So we make a transparent insertion, if you like, into the layer 3 routing decision. That's ingress routing. There'll be some attachments needed for Transit Gateway, but actually only in a later module. So you won't have to do this for module 1, nor that. And your completed architecture will look something like this. I've got one more. There we go. So you'll configure ingress routing for both the website and the edge VPC. You'll do your Transit Gateway attachments if you get to modules 2 and 3, which would be great if you did. And there'll be some route table configurations inside Transit Gateway to move your packets around as well. All right. So workshop objectives. Your task, if you choose to accept it, you need to meet the compliance requirements of the business. You'll earn points for successful checks and lose points for unavailability. So we're checking to make sure or ensure that when you're doing your implementation, you don't break routing altogether and bring your product down, right? So we want to make sure that as a primary concern, you get the routing in place, which should be relatively straightforward, and we're going to guide you through that, don't worry. And then after you've done that, your second priority is to implement the inspection. So hands-on modules. Let's have a look at these. Yeah, so 2 and 3 are a bonus. The first thing you're going to do, you're going to download a file for module 1, a PCAP file. We're using the SuriCata PCAP generation method for this workshop. For the point of having a look at the traffic that's flowing through your instances. You're then going to inspect that PCAP file, and you're going to look for some HTTP headers. I can tell you now. Spoiler, there are 3 headers you need to look for. But Jesper's going to walk you through that. Then you're going to write a Lua script. We've given you an example. You just need to modify it. I'm sure you all know how to write Lua scripts. So, and then you're going to write a rule to reference the Lua script to block the traffic. And then you can check your health dashboard. And once you've checked your health dashboard, you should see the graphs go up to available, and you'll see meeting the checks. The important thing is to focus on module 1. I would say check the dashboard regularly because that can show you whether you've made a routing decision, but more importantly, make sure you have fun and you learn something from this. And if you've got any questions about the implementation, then let us know. Your dashboard looks like this. So once we give you access, which I'm going to give to you in a second, and then I'm going to hand over to Jesper, looks like this. So once you've logged in, you'll see your overall scoring for your account. Like I say, it's lightly gamified. It's not too competitive. It's just to add a slight dimension to this. You'll get console and CLI credentials, which you'll be able to click on a button. They'll give to you, which you can just paste straight into your terminal, which will give you API access to AWS. You'll get your lab instructions on the content guide. And then if we're feeling particularly nice, which we are, we will share the completed rules in the output section there. We might do that sooner. We'll just share them with you so you can see what the working rules are. All right. Right on time, I think. So we've spawned 150 accounts for folks today, and folks online. Hello, can't see you, but you can click on any one of these links to get you to the AWS login page. When we run out of accounts on one, you'll probably get an error saying the event is full, but there should be enough. Don't click on both, because then you'd have 2 sessions. You can get the course guide and instructions from there, and if you've got any questions now, you can ask us, but actually after the workshop, feel free to take a copy of that alias and then reach out to myself. You'll get through to Jesper, Max, and Scott Morrison, who couldn't be here today. He couldn't travel, so. And with that, I'm going to hand over to my colleague Jesper, and he's going to walk through Module 1. Is everybody able to click on that link and get to the login page? Yeah. That was about the best concatenated, or reduced, rather, URL I could generate. We nearly put a QR up there, but figured that most people would probably be using their computers, so QRs aren't that useful. As we go through this, if you want to throw your hand up, if you get stuck, you have a question, myself and Max will come and speak to you and get you going. Oh yeah. Already done. Already done. So you'll probably, when you get to one of those, you'll probably have to choose, I think it's the first option, use your personal or corporate email, and then it will email you a one-time passcode. Is that working for everyone? Yay, nay? Anyone in successfully? Yes. Brilliant. All right. Leave that for a sec. We're going to switch the laptops over, but we do have these links on the next presenters. So if anyone's still struggling to get in, you should have the links in a second.
Hey guys, if you're looking for the links, it's in the talk channel under the AWS Awesome Guys workshop. Okay, so if you were looking for it in the general channel, it's not there, it's in the talk channel.
Thank you.
Yeah.
Perfect. All right, so I'm gonna walk you through the actual first module here. And yeah, everything I'm going to do is going to be done live. I mean, what could possibly go wrong, right? And the Wi-Fi has been a little bit so during the day, but hopefully we will manage. And if it is too bad, yeah, you can just watch me go over it. So. Essentially, what you will need to care about are 2 different pages. So what you have is one Workshop Studio page, and it is in this Workshop Studio page where we have all the different modules, the labs, and what you should be doing to be basically compliant. So today we are focusing on module number 1 here. Which have one primary requirement, which is setting up the actual subnet routing. And then we also have the secondary requirement, which is setting up IPS and Lua scripts. But when we have been doing this workshop at the AWS events, for example, and with our other AWS colleagues, we have been obviously talking quite a bit around from the AWS point of view. But since we're here, I would like to try to turn that around and talk more about from the Suricata point of view. So when I will go over this module 1, I will not only follow all of the points here. I will show you around some of the integrations that we also have been doing, and how we have actually automated and created the Docker containers, for example. And also, what I also would like to mention is that the actual inspection VPC, so the VPC where we have the Suricata containers deployed and so on, that is all on GitHub as well. So here we have the basics set up, how we are building like the Docker containers, how we have the default Suricata configuration, and so on. But again, I will also walk this through over in the actual workshop as well. So the second page that you have to really care about is the AWS console. And I don't know, how many here have been using AWS before? Raise your hand. A few people. That's good. So, I mean, when interacting with AWS, you can interact with it in multiple ways. So my preferred way is using CLI. However, in this workshop, we will be using the UX, so what we are calling the actual AWS console, which is the graphical interface. And AWS is built up by multiple types of services. So it's infrastructure services such as virtual machines, for example, containers, storage. But then we also have, what can you say, like higher level services as well, such as maybe machine learning services. We have logging services, etc. And one of the base fundamentals when it comes to deploying Suricata or really any other firewall really on AWS is that you're usually doing this using the infrastructure services. And in this case, that includes virtual machines, containers, and also VPC, as Adam mentioned quickly. So going over to the VPC service, we can here see, hold on. Let me see, so my tether is working. Should be fine. We should see a number of VPCs here. So we have 5 deployed as of today, where one of those VPCs, the filter VPC, is the actual VPC where we have Suricata deployed. And the other VPCs are for the actual different modules. So in module number 1, we will essentially only care about the website VPC. And in this website VPC, we have, for example, a load balancer deployed. And we also have a simple Apache web server deployed as well, which is acting as our website, essentially. And our objective is then to protect this website using SuriCata. So if we go back to the actual workshop module and looking at the primary requirement, it is essentially 4 steps that we need to do. And the very first step is to deploy the Gateway Load Balancer endpoints. So I have already prepared my environment some. But if we go here to go back to the AWS console, and we go to endpoint services. So already in your environment, you already have what we're calling a Gateway Load Balancer endpoint service running. And this is, as Adam mentioned quickly, if I go back to the presentation here, it was one on the first slides, I believe. Yeah, this one. So if we look at this one, we have the filter VPC here, or what we're calling the provider VPC. And it is in this VPC where we actually have the Gateway Load Balancer and the SuriCata fleet deployed. And then we are sharing this Gateway Load Balancer to the website VPC in the module 1 case using a Gateway Load Balancer endpoint. So in this case, we have the endpoint service here, and we then want to deploy the Gateway Load Balancer endpoint in the website VPC. And to be able to do that, we need to share the endpoint service ID, or the service name, which is this long ID here. We go back to endpoints. We do create endpoint. And when we are creating VPC endpoints here, we have different types of already pre-made endpoints. So you can essentially use AWS services, marketplace and partner services. But you can also use what we're calling here other endpoint services, which is what we're going to use here today. So here I paste that very same ID. I verify that this ID actually exists. And here I can then choose where I want to actually deploy this endpoint. And I choose the website VPC. So in this case, going back to the slide here again, we have the Gateway Load Balancer. And what I've been doing now is that I've been creating the Gateway Load Balancer endpoint into the actual website VPC. So I can select one subnet here I believe it's in the firewall subnet, and then click create endpoint. So I have already done this, but if you are following along, feel free to do it yourself. Are you following me so far? Any questions? Perfect. So in the end, you should have 2 different endpoints in your website VPC. And why do you have 2? Well, it is because, going back to the slides again, just to show you the actual architecture, you can see here that we have 2 different availability zones. So we are essentially deploying one endpoint per availability zone. And that is because one availability zone, I mean, just to make it easy, you can think that one availability zone is one data center. So what we want to do is that we want to keep all the traffic inside of one availability zone as much as possible, because that means lower latency, lower cost, and so on. All right. So that was step number 1. So after we have deployed this gateway load balancer, we have to configure the actual routes in this VPC. So what we want to make sure is that every time we are sending traffic from the internet towards our website, that traffic should be filtered through the SuriCata instances. So what we need to do is that we need to configure the routing tables in these different subnets, just so we can control, in that case, how the traffic is actually floating or is being routed inside of our VPC. So the first thing that we need to do is that we need to change the default route in the firewall subnets. So this makes sure that whenever traffic hits the firewall subnet, that traffic is always routed towards SuriCata. The third step is that the public subnets, and the public subnets, you can think about a public subnet as a traditional DMZ, essentially. So it's usually in the public subnets where you have your load balancers, for example. So in this case, where we have our load balancers in the public subnet, we want to make sure that that the public subnets are also routing towards the gateway load balancer. So in this case, whenever we are getting traffic into our VPC, we can make sure that it first gets routed to the public subnet, and then from the public subnet to the actual SuriCata instance, so we can filter the actual traffic, and then from that subnet towards the website or the private subnet where our website is located. So doing this using the console is usually a lot of clicks. So I have also prepared this, but I will show you the actual configuration. So again, in your VPC console, so you have, to the left here, you have VPCs, you have subnets, and you have route tables. So since now we want to modify the route tables, I click on route tables here. And since we are running multiple different modules here, we will have a bunch of routing tables. However, I only really care about the routing table that starts with website VPC, I think. Yeah. And if we go back here to see what we needed to change, so the second step is to change the default route in the firewall subnets. So finding out the firewall subnets. Let's see, yeah. So in the firewall subnet for subnet 1, so the subnet in the availability zone 1, we have to add the default route pointing towards the internet gateway. And the internet gateway is essentially the ingress point or the egress point towards internet. So if you don't have any internet gateway on your VPC, that VPC is fully private, and it cannot connect out to the internet, for example. But in this case, since we are running like a public website, we want to have this internet gateway. So in that case, what you're doing is that you're adding the default route and pointing that towards the internet gateway. And you do the very same for the second firewall subnet as well. So you should both do it for firewall subnet 1 and firewall subnet number 2. Just making sure, there we go. So checking routes here, should have it there, and we should have it here. Perfect. So going back to step number 3 then, where we should edit the public subnet's default route to point to the respective zonal gateway load balancer endpoints. So in this case, here in this routing logic here, we are creating or we are building the logic that the traffic should try to actually stay within the same availability zone, so in the same data center. So we have to go back to the endpoints here. I'm opening that in a new tab to make it easy. We select one of them here, and we can click on subnets. And we can here see that I'm going to rename this one just to make it easy. VPCE in subnet 1. Okay. Okay. Demo ghosts are here, I think. Anyway, it doesn't really matter. It's just a name. It's just a metadata thing. Anyway, so we can see that the ID then that ends on 27B is in firewall subnet 1. So again, going back to the routing tables, the routing tables here, we go to the public subnet and to public subnet 1. And in this case, we add the default route pointing towards the ID, in my case, that ends with 27B. So what this would look like is this. So adding default route towards gateway load balancer endpoint, and then 27B. So this makes sure, if we go back here, that whenever traffic enters availability zone A here, the traffic will actually stay in this availability zone, because the public routing table in this case, public routing table 1 in this case, are just corresponding with the public subnet in availability zone A. And then for public subnet 2, which is corresponding with public routing table 2, are then routed towards the firewall endpoint that is stayed in availability zone B in that case. Okay. And when you are done with that, we have to create a so-called edge routing table. And this edge routing table is what we are associating with the internet gateway. So whenever traffic enters from the internet gateway, so in this case ingress traffic from the internet, we want to have a routing there saying, okay, the traffic that is routed towards the website load balancer should be routed via the network firewall, or the gateway load balancer, so the SuriCata firewall. So what you do is that you create a new routing table. You can name it Edge VPC, for example. and you then click Create. And when you do that, you would find it in your list here. And what you then need to do is to add those specific routes. So in this case, we add 2 different routes. One of the routes are 10.2.00/24, and this is the CIDR range for one of the website VPCs, and the website VPC, or the public subnet, the public subnet in the website VPC in availability zone A. So that one should then also be routed towards the actual same gateway load balancer endpoint in that very same availability zone. So in this case, the one ending with 27B. And then we're adding another route. But instead of pointing that to the availability zone A gateway load balancer, we're pointing that towards the availability zone B gateway load balancer. So in that case, the destination should be 10.2.1.0/24. So all the traffic that is going towards the network load balancer in public subnet 2 will then get routed to the firewall endpoint first, so should be inspected by SuriCata. After we have added those 2 routes, we need to associate this edge routing table with the internet gateway. And so what we do here is that we do edit edge association, and then we select the internet gateway that we want to add this routing table to. So in this case, we will only have one here, and so we just select that one and click Save Changes. So in this case, we should actually have a full routed. We should actually have a full flow now towards our website, which is that all internet traffic going towards our website will automatically first flow via SuriCata, and then to the network load balancer, and then to the actual website. So to make sure that that works, we can go to what we're calling the EC2 console. And EC2 is the service for creating virtual machines, essentially. So in this service, we also have load balancers. So in AWS, there are different types of load balancers. And in this case, we're using the load balancer called network load balancer. So, and since per default now, this is a publicly available website, we can, just to check if this quickly works, we have a DNS name here, which is public. We copy that, and we can just do a curl towards this one, and we should get the response, which we do, thankfully. So in this case, what we're doing, so since we are essentially just doing a bump in the wire, from the user perspective, they don't see that we're going through a firewall or through SuriCata like in this case. We just get the ordinary response that we would usually get from this website, which is just app1 and initializing. So this was very AWS specific, right? So I mean, how we are routing traffic within like a VPC and so on. Now that is done. Now we can actually do and concentrate on the SuriCata things. So going back to the Workshop Studio page, we can now look at the secondary requirement. And this is where we are actually adding new rules, and we are actually configuring Suricata. So I think I'm gonna not follow this 100% now, because I would rather talk about the solution overall and not the specific things that we actually need to do to be compliant here. So I will start by saying, so per default, and to be able to finish module 1, what we are doing is that per default, in our default Suricata configuration that we have deployed, we have PCAP enabled. So we are capturing all the actual traffic that is saved locally on the Suricata instances until the PCAP file is 4 or 5 megabyte large, I think. And when that happens, we then upload it, that PCAP file, to a centralized storage called S3. And the S3 is a object store where you can essentially, we are just using it very basic here. So we are just going to use it to have a centralized storage for all our PCAP files. And we can then download the PCAP files from here. So for example, so the naming convention is essentially the bucket name. So my unique storage area, and then today's date, and then a number of PCAP files here. And those PCAP files are coming directly from the Suricata instances. And I can download these and run them in any PCAP application. And we also, I mean, what we also have is the possibility, so we actually have a quick start where you can start another Suricata instance, for example, and then rerun traffic towards that Suricata instance using those PCAP files as well. But that is not part of this workshop at all, unfortunately. Anyway, so this is a little bit on how we are doing with PCAP files in this case. And I mean, in a real-world scenario, you probably wouldn't have PCAP enabled all the time, as we're having here, which makes me want to talk a little bit about how you can actually interact and configure Suricata. So, I mean, so in this case, we have spun up 150 accounts, right? Which means 150 unique Suricata fleets. And to be able to do that, we need to have a fully automated deployment, fully automated configuration, and so on. And to be able to do that, we are using a GitOps workflow, as Adam spoke quickly about. And I would like to dive a little bit deeper into this, what that really means, and how we are doing it. There are probably hundreds of different ways that you can leverage like a DevOps way of working together with like infrastructure and so on. But this is how we have been solving it. So we are using a very much a Git-heavy like approach here. So in AWS, we have a Git service, but I mean, it's just a Git service. And so you could use essentially any Git service as you want. I mean, you could use GitLab, you can use GitHub, you could use the Atlassian stack, whatever, right? And in this case, we're using code commit, which is the AWS Git service. And in our Git repository, we have a few different things. So the first thing that you see here, the CloudFormation, is our infrastructure as code templates. So it is using CloudFormation, we're actually deploying the Suricata fleet. And in this case, the Suricata fleet is 3 different virtual machines, and each virtual machine runs 2 different containers. So we have the Suricata container, which is runs the Suricata engine, and then we also have this sidecar called rules fetcher, which I will talk a little bit about in a second. And then we also have Docker files. And it is in Docker files we're essentially configuring Suricata. So we have 2 Docker files, one Docker file for rules fetcher and one for Suricata. And it is in the Suricata one, for example, you would have essentially the same possibilities per se to configure this in the Docker container as you would directly in a virtual machine or or directly on a hardware server. So what we are composing here in the Docker file are the full etc catalog, or the Suricata etc catalog, essentially, or folder, whatever. And it is here you have the ordinary Suricata configuration file. And per default, we have a bunch of stuff enabled, disabled, and so on here, just that it should fit this particular workshop. However, you can change this directly here in Git. So either using the GUI or using your ordinary preferred Git tools. And when you are changing something, in this particular case, in the Suricata configuration, what we are then doing is that we are actually triggering a full CI/CD pipeline, which looks like this. So in this case, the first step is that we are listening on changes inside of our Git repository. And depending on what we actually changed or added in this Git, we are running different types of build stages. So in the case of us changing the Suricata configuration, for example, we are running a build stage, which is called build Suricata container. And when this is built, we are essentially recreating the Docker file. We are creating the Docker image, and we are then creating that then with your new Suricata configuration. And we are then deploying that into our virtual machine fleet. And how many here have been using container orchestration systems such as Kubernetes, for example? Some of you? Good. So usually, I mean, when I'm running containers on my computer here, I mean, I'm just using, ordinary Docker, which works fine, and we're using Docker here as well. However, that works fine in a small-scale environment. Usually, if you want to run containers across a number of virtual machines or a larger amount of fleet, you would need an orchestration system to actually do that. And Kubernetes is the one that is the most popular today, I would say. We are, though, not using Kubernetes in this case. Instead, we are using an orchestration system which is called Elastic Container Service, which is more, I would say it's more native to ordinary Docker than Kubernetes. So it's pretty easy to get used to. So when we are then, in this case, have changed our Suricata configuration, we have rebuilt our container, we are then uploading this new image file to the image repository. So in this case, we should have a repository here. Yep. Jesus. Good naming. We checked. That was okay. That was for rule fetcher. So you can see super good naming here. Rules fetcher and SuriCata. So in this case, since we didn't actually rebuilt it, we just have one image tag here. And when we are uploading a new image here, a new image version, essentially what we're doing is that we start to deploy this image across our fleet. So going back to ECS again here, we have something called cluster, which is essentially the infrastructure part. And then we also have task definition. And I will start to talk about the task definition first. And a task definition is, in this case, you could say like the deployment pattern, maybe. So in this task definition, we can see that we have two containers. We have the SuriCata container, and we have the rules fetcher container. And as soon as we are doing or redeploying one of these containers, we are essentially redeploying both of them. And how we are doing this is that we are building a one-to-one relationship between our containers and our virtual machines. So in this case, it means that whenever we are spinning up a new version of SuriCata, and a new version of SuriCata in this case could be a completely new SuriCata version, but it could also be a configuration change of your SuriCata engine. So so when we are deploying this, we are using the task definition, and we are deploying the task definition on our cluster. And a cluster in this case, our cluster contains of the baseline of 3 different instances, which is called EC2 container instances. And that is ordinary virtual machines, basically. And on these 3 container instances, we are running 3 different tasks. And one task is essentially one task definition. So today, when we are then redeploying SuriCata, we don't want to have any downtime of doing that. So what we are doing is that we are deploying 3 new, or maybe 2 new more instances. We are deploying the containers on those instances. And when they are ready and ready to start to serve traffic, then we are starting to remove the old ones. So, I mean, when it comes to flows, etc., they would be reset because it's completely new instances, right? But, I mean, if the clients are can work with, reestablishing sessions and so on, the client and the users shouldn't notice any particular downtime in that case. Yeah, sorry.
I was just curious about one thing. I mean, I was poking around. I was trying to understand what sends back the unique packets. Right? I mean, the gateway load balancer is back to see the packet, I guess, and then send it.
Yeah.
I didn't find anything in the Docker file that last time.
Good question. Of course. Yeah. So the question was essentially how the integration with the you need. Sorry.
No, we're good.
Okay. So the question was how we are integrating the Geneve tunnel with SuriCata in this case. So how we are sending back and forth the actual packages from to and from the client, for example. And that is not happening inside the Docker container. You're completely right. We're doing that on the virtual machine level. So very good point, actually. So going back to the Git repository here. So when we are setting up the virtual machine, So when you are creating Docker containers or running any containers really, they can interact with the host networking system in many different ways. So what we are doing is that we are giving essentially full-fledged access to the host networking. So in that case, we are, let me see here, I believe it's in this one here. So, so this is the CloudFormation template, and so this is the automation or the infrastructure as code language that we are using to spin up the EC2 instances, which we are then deploying the Suricata containers to. And when we are deploying those instances, we are running something called a user data script, which is essentially a bootstrap script. So going down to user data here. So what we're doing is that we are creating something called an auto-scaling configuration. And it is this auto-scaling configuration that makes sure that we can spin up new instances, and we can spin up instances when we are updating the Suricata containers and so on. And it is when we are spinning up those instances, we are doing the actual Geneve configuration, and how we are then using IP tables to actually forward the Geneve encapsulated packages towards NFQ in this case. So we are using the NFQ the networking integration on the in the container, because that has the full access to the actual host network, and to be able to receive all the packages from the Gateway Load Balancer. And we are then also, when we are creating this instance, we are setting up pre-routing and post-routing using like IP tables. So what we are doing here is that this little for loop here is essentially first finding out the IP addresses of.
Okay, it's working. It's cool. I see that you are using the GNFQ. Did you try the multi-queue capability of Suricata? Because it's quite nice to scale up a little bit the performances.
Not sure if we did, to be honest, but that is. Yeah.
Yeah. So you do something like -GNFQ, I don't remember the syntax, when you can specify, I think it's scale up nice up to 8Q. And then you listen on 8Q on Suricata, which means that you can have 8 workers instead of one single one.
Because that is actually one of the reasons why we are doing this one-to-one relation of the Suricata container and in a host. Because as soon as we are trying to spin up another Suricata container on the same host, we get that, yeah, you're using the NFQ queue, right? Thank you. Exactly, and this is exactly what we are looking for, because we are not experts on Suricata per se, so any feedback is super helpful. But yeah, going back to the first question that I got, was this what you were looking for? Perfect, perfect. We have a few more minutes, so let me talk a little bit about the rules as well. So we have different ways to add rules. What happened here? There we go. So we have 2 different ways to add rules. So we have So usually when building with Docker containers, it's very common to have like a static configuration and a dynamic configuration. And what we mean with that is that a typical static configuration is something that should be handled and versionized together with the actual Docker image. So in this case, from a Suricata point of view, it could be that I'm writing a set of rules, and I want those rules to be tied together with a specific Suricata configuration or to a specific Suricata version. So in that case, we are adding rules directly in the Docker container using a file called static.rules. And all of the rules here will be essentially tied together with the Suricata version and the Suricata configuration in that Docker image. We also have what we're calling dynamic rules. And those are probably the ones that you are typically using. And those dynamic rules are handled outside of the Suricata configuration and outside of the Suricata versioning and so on. And when doing a change here, which we are actually doing in, if you're following module number 1, is that we are adding a rule here. And when we are adding a rule here, going back to the pipeline steps, here we go. We have a step here which is called copy to S3. And this is where our sidecar container rules fetcher comes into play as well. So when you are doing an edit in that dynamic.rules file, we are not rebuilding Suricata. We are not redeploying it. We are not doing any changes to your current running configuration. Instead, what we are doing is that we are uploading the dynamic.rules list to S3. So in that case, I believe it's in the code pipeline here. Probably under deployment. Yeah, dynamic rules. So the little sidecar container, as we are calling it, and the rules fetcher. Let me see. You can probably have a look at it. So that small rules fetcher container is always running alongside of the larger Suricata container. And that one is actually looking at the dynamic.rules file in S3 like every 10 seconds or so to see if there are any changes. So I think it's just a small shell script here. And there we go. Yeah, so not super convenient maybe to walk through it here, but essentially what it is doing is that it is downloading those dynamic rule sets. And if it notices that, okay, there has been any change in these rule sets, and we are using MD5 checksums for that, then it will actually trigger a Suricata rules update. And so so that small sidecar container and the Suricata container are actually sharing the same underlying storage. So when we are noticing a dynamic rule change, we are then in the larger Suricata configuration or a Suricata container running an update which is called rules_updater.sh. And this one is then triggered from the sidecar container. And what this does is that it's just running Suricata SE reload rules. So one thing that I had in mind here, instead of using like a Suricata CLI or a Suricata command, is to leverage something like an API call instead. But I have not been able to actually find that. So this is how I am solving it. So the dynamic rules here are, so as soon as you want to add or remove a rule, that should take roughly 30 seconds from editing in your Git repo file to when it is actually deployed. And using the pipeline here, we have a very basic pipeline per se. So usually what you probably would like to do is to have two different environments, like a production and a test environment. So first you're deploying this to test. So you're testing the dynamic rule sets in test. And if that is done, or if that is okay, you're then continuing to deploy this into production. So, I mean, using this GitOps approach, you don't really have to, SSH into the servers and go log in directly into the OS or directly into the containers. Everything could essentially be handled using Git, which means that everything is versionized, everything is logged, and so on, out of the box. I am 2 minutes over time. I would like to show one more thing, if that's okay.
You can go another 15.
Oh, wow, perfect. Or am I boring you?
Are there any questions?
Okay, good.
Let me bring the... You can throw this, right? It's a throwable microphone, I think. I'm not going to chance it. I'm going to bring it to you. Thanks.
Yeah, I had a question about your use of Suricata update. Do you support just changing the rules or actually using the modify comp and disable comp, et cetera?
So we actually, we should support like more, I can say, advanced use cases such as like disabling and so on. I haven't tested it though, but I don't see why it shouldn't work, to be honest. Because another thing. So looking at the deployment. So no, I'm in the wrong. Here we are. So going back to the GitHub repo. Something that I haven't showed you is that we are also supporting like adding open rule sets. So in the CloudFormation template here, so even though CloudFormation is usually used for infrastructure and infrastructure automation and configuration, we are also using it right now to actually be able to add open rule sets, for example, and the Maximind, the API keys, and so on. So if you are, so this is called like parameters. So in this case, this is just an example of parameters. You can have hundreds of these. And so what you can do here is that you can add Suricata rule sets like etopen, for example. And you do that using like an ordinary list. And when we are adding or removing rule sets in that parameter, we will actually also keep those up to date. So adding, removing, and so on. And same with the Maximind API key as well. And this is when you're deploying this, since we are for the Maximind example here, then we are actually redeploying the Suricata container because that's a change in the Suricata configuration file. Right.
I think what we would say is it's fairly extensible. We were
Yeah.
just scratching the surface with what we could do with this, and Jesper's probably right. Perhaps we shouldn't have parameterized that. I think at the time it was a relatively straightforward way of doing it, but
Exactly. I mean, from a container perspective or from a real cloud native perspective, you should probably have that as a container parameter or environmental variable instead. But yeah, this was just quicker, I guess. And we are also, so when we are setting up the Docker containers, we're actually on the virtual machines running a logging, like a small logging agent. And this logging agent are automatically ingesting logs, such as the Eve log and really any log that you want, actually, from Suricata into the service that we are calling CloudWatch. So per default, we are logging from a bunch of different destinations. So, but Eve is probably the one that I am using the most, at least. And these one are then, in this case, creating one log stream per virtual machine or per Docker container. But you can also use something like log insights in this case to actually run a query across all your Eve logs, for example, out of the box as well. And those are ingested in near real time. I believe it's every 10 seconds right now. But you can make that faster as well.
Jesper, one of the real nice things about this is how customizable it is. Because once you've got the logs in that format and they're in CloudWatch, you can chain services together. You could call a Lambda function. You could call a messaging system. I think last year we demoed a particular packet or matching like a tuple and then generating an email. A rudimentary example of what you can do, but you could use Lambda for deploying a new rule set, for example. You could match something and then say, hey, I'm going to block this traffic, and then update the rule base and push it straight back out.
Exactly. Yeah, so I mean, so in this case, you can write, basic filters, for example, and so on. And you can, in this case, then create an alert or create a dashboard out of this query. So, for example, so looking at, the Eve log, and if there is a specific log that I want to alert on, I can create like a query for that, and ingest that into whatever monitoring system that you want to use, essentially. Yeah. So I think this was all that I really wanted to show. Open to. Thank you for the questions during the actual time, and open for more as well.
I have a throwable microphone. Anybody? Looking for pointers here. How can we improve this? You the Suricata experts in the room. I'm going to try throwing it this time. You ready?
So the architecture looks like it might support what's commonly known as flow bypass to limit inspection of like encrypted traffic past the handshake. Is that true or?
I'm looking at Adam here as well.
Well, I mean, that's built into Suricata already. I just wasn't sure how well it would be supported in the Geneve protocol, number one. And number two, typically when you bypass a flow, you lose access to, say, counting the IP header length or something like that, right? That would be nice if you could bypass the flow, but then still provide bytes sent and received for the total flow.
Yeah, so I'm not quite.
Right, and so like in educational networks where I've seen this discussed, they're using like SD-WAN solutions, and the switch continues to count the IP length, and then you can use that to do like a producer-consumer ratio analysis to look for exfiltration, rather.
So,
Interesting question, actually. In theory, yes, because it's EC2. Oh, yes.
Yeah.
yeah.
Hello. In theory, yes, because it's EC2, right? So we can pull metrics off the EC2. It might not be coming from the Suricata engine, but
Yeah, you can also use the connection tracking entries from NetFilter to extract the information about the flow. The only thing that you will need to do is to be able to have a mapping between the flow ID of Suricata, because as soon as you start to bypass from NetFilter, you will get, as soon as you bypass in Suricata, NetFilter will let the packet go through, but there will still be NetFilter connection tracking. So
Right.
the advantage is that you go NetFilter speed, so kernel speed, or not Suricata speed, so that's cool.
yeah.
But if you want to get the volumetry like the person there was asking, you need to do a mapping between the connection tracking flow entry in NetFilter and the flow inside Suricata.
Yes. Yeah, so because it's running on EC2, obviously we'd have full access to from the provider perspective. We could pull that and pull that together. This is where someone needs to create some pull requests on our code and say, hey guys, you could make this better by doing this, or could you do this feature? Yeah.
Yeah, because I mean, in the Geneva protocol perspective, from the Geneva protocol perspective, I believe that. So, I mean, we are encapsulating like the raw package, right, in Geneva.
Yes.
So, I mean, we shouldn't really lose any data.
Yeah. So yeah, if it potentially would bypass the Suricata engine, but we'd have, the data would be there anyway, wrapped up in Geneva, and we could find a way to export that and map that somehow.
Exactly.
So yeah, in theory, yes. Sure. Anyone else? Anything that scared you about that? Do say. What we wanted to do, like I say, right at the start, was show the open source community that the Gateway Load Balancer framework was not just for partners with, vendors with licensable services. It was for anyone that could essentially use Linux to build a service and bring their own code. I hope we've done that. And we'd like it to be more extensible and improve it and put new features in there. We should probably lift the code to 7 when that's GA. When is that GA?
Probably in early January, but I would recommend going to 608 as soon as you can.
Yeah, I believe it's 603 now, but yeah.
Yeah. All right.
Yeah, I do have one question. What kind of operational costs does it add to throw Suricata into an existing infrastructure or add it? I mean, like, how much does it really cost from a currency perspective?
In terms for a customer, well, of course, if you were to build on AWS, any customer would pay their EC2 charges as they would in any data center, either on-prem or in the cloud. To run this solution, I don't know if we ever did the full cost analysis on what this would cost. There are some costs for things like ECR repos. There's Gateway Load Balancer charges.
So, the two main charges that comes to mind are the Gateway Load Balancer and the actual virtual machine, so the EC2 instances. When it comes to like the CI/CD pipeline, like the code commit and the container orchestrator and so on. So the container orchestrator is included in the EC2 cost in this case, and both like the Git is, we're talking a few cents a month.
Yeah, and code commit is actually, I believe it's free under 5
Yeah,
users as well,
exactly.
and X number of commits and requests. So it's worth looking at the pricing calculator for things like this, and then sort of weighing that cost against the operational improvements it gives customers as well. Sometimes it's not always about cost, but it's a valid question. So generally, the compute power you'll pay for in the form of the container instances, these C5s that we spin up. They're pretty beefy instances. But if you wanted to model this, you could go into that config YAML file out of that cluster JSON file and change that to a T3 or a micro instance, or real sort of test it low level without incurring too much cost. And some of those instances are actually in the free tier, depending which ones you use, right? So.
Exactly. Yeah, it's a very, very valid question. I'm just gonna. So I believe I have it up here. I don't think I have access to it in this.
No, we can't show the billing console
no.
because this is
It's
an
a
event.
workshop.
Yeah.
Yeah.
It's a special type of workshop engine. It doesn't show the master billing account. But it's a great question, actually.
Yeah.
Maybe we should model some scenarios and then
Absolutely.
put them in GitHub.
We should.
Like this.
Because one very, very common case for this is, so what we are essentially doing here, when we are creating those EC2 instances, which I mean from a cost perspective will be the larger cost. What many are doing is that they are using like auto stop, for example. So in test and dev environments, they're just running those during office hours when you're actually testing the rules and building rules. And then during non-office hours, we are just running the production environment. Those type of things help you save cost as well. But for sure, it's the EC2 instances that will be the first cost.
I noticed on your brainstorming session, which you're doing next, there was a line that talked about cloud. So I'm interested to know what your visions are for that, how cloud can help you, you know, in terms of development, in terms of code release, all that type of stuff. You know, where are the pain points you're feeling today not using cloud? And where would cloud help?
Yeah.
With that, thank you for your time. Oh, one more question. Yes.
Small question.
Yeah.
Wait, Corrado, wait for the mic. The virtual folks can't
Yes.
hear you when you're shouting.
Yeah,
We
right.
can repeat it. Yeah.
So, Gateway Load Balancer makes a lot of sense when you want to do prevention, right? When you want to block things and so on and so forth. If I want to do just visibility, I just want to have visibility over the packets. Yes, I can create an IP table, role to send you back the GNIF packets, but it's kind of silly. Is there a way to configure the Gateway Load Balancer to just say, okay, send me the GNIF packets, but not expect the packet back, and don't assume I dropped them, or would there ever be?
The Gateway Load Balancer, because the way Gateway Load Balancer works is it takes a wrapped up client packet in the Geneve, wrapped up in Geneve, decapsulates the header, looks at the payload, puts the Geneve header back on, sends it back out if it hasn't been dropped, essentially. So what would be the use case you'd want to... Is this for passive monitoring?
Yeah, exactly. I want to be passive. So.
So interesting. So, well, particularly with AWS, we have a feature called packet mirroring.
Yeah.
And those packet mirroring service can absolutely work in an IDS modality as opposed to the IPS. What we've deployed here is IPS, inline packet inspection, taking affirmative action. But absolutely, there's ways to do this with Gateway Load Balancer in a sort of a... I think with mirroring now, we do Gateway Load Balancer as a target of VPC mirroring. So yeah, there's ways to do it. And you could actually do it without Gateway Load Balancer. In fact, just doing mirroring to an EC2 instance with SuriCata running on it, and customers do that. Yeah.
Thanks.
Yeah.
Excuse me.
Just while we're waiting for the mic, we did pop up a survey link here so we can improve this session. If you do have 2 minutes, 5 radio buttons to check. If you get a chance, do that survey, please do. You can scan it with your phones.
Since you are having the IPS setup, have you also measured latency as well? Does it somehow, are services affected by the latency of the SuriCata engine?
Do you mean in IPS mode or IDS
Correct.
mode?
IPS.
There's extra hops, right? There's extra instances to go through, extra interfaces. So we're adding, in some places, probably microseconds of latency. In other places, maybe a couple of milliseconds. Haven't done the detailed analysis on this. But yeah, we're going through more compute, more interfaces, essentially to get the packet from A to B. It goes through X, Y, Z before it gets to B. So.
Right.
Yeah, the most pain point we saw was the throughput actually when enabling PCAP. That was the bottleneck. Latency was okay, I would say. I mean, it was in pair with similar solutions. Of course, that also depends on which rules you're using and if you're using Lua scripts and so on. But overall, latency wasn't anything that stood out, so to say.
Okay, thank you.
Yeah, I think that's right. I think overall throughput when using that feature is one of the things we ran into when we were sort of doing a little bit of benchmarking. Okay. Well, thank you very much for your time. It's been a pleasure to present and run this workshop with you, and hope you got something out of it. And it is available for another few hours, so if you have some time, feel free to play with it.
Yeah, 48 more hours, I think.
42.
42, yeah.
46. 46, yeah.
Perfect. Thank you so much.